All right. So, before we can start into the methods, we need to talk about dividing by numbers. Okay. If I want my answer to be bigger, would I divide by a smaller number or a bigger number? A smaller number. The smaller number will give you a bigger answer. So, if you look at number 1, would I want to divide by 40 or 45 to get a bigger answer?
40.
I'd want to divide by 40. Okay, so if I want a final answer that's larger, I want a smaller divisor. So what would I want in number 2 then?
9.02.
9.02 will give me a larger number. What would I want in number 3?
The first one.
The first one. And what would I want in number 4? The first one. Okay, I would want that first one. Okay.
Yeah, you lost me.
Right, we haven't even done nothing yet.
Right. You still lost me.
You want the lowest?
Oh, you want smaller numbers.
Okay, so here, hold up. Okay. I can wait. It's fine. I'm not going to fight you on this. There's a video up on YouTube from last semester you can watch. I don't have to teach it. Okay, so if I have, I wonder if it actually works. Okay, if I have 100, okay, and I divide 100 by 10, what does that give me? 10. If I divide 100 by 5, what does that give me? 20. So, when I divide by a smaller number, my answer comes out to be bigger. If I divide by a bigger number, my answer comes out to be smaller. So, I want a larger number. So, they want to know, should I divide by 40 or 45? Which one's going to give me that bigger answer? So, in order to get a bigger answer, you want to divide by the smaller number. Okay? That's all that's saying right now. Because you're going to need, this is what's part of the guessing game for this section. Okay? So, in the next set of 4, I want an answer that's going to be smaller. So, if I want an answer that's going to be smaller, I need to divide by the bigger number. So, in number 1, I want to divide by 36. In number 2, I want to divide by 0.82. In number 3, I want to divide by 0.23. And in number 4, I want to divide by 734. Perfect. Okay, so this is the guessing game that's going to happen. Instead of giving out those extra seats like Hamilton's method says, now we're going to sit there and we're going to change your standard divisor. And it's now going to become what we call a modified divisor. We're going to sit there and guess and guess and guess until your lower quotas equal out to be what we need. So this is what becomes a pain in the butt. Because if you're not good at the guessing game, this sucks. Okay, so I'm going to try to help you get better at the guessing game. We'll talk about it as we go. So it's just more examples of what we just did. Breathe. Breathe.
Like, I'm breathing.
Woo!
I'm still living, so.
You're right. You still live. All right. So right now, I'm dividing by 6. I want my answer to get bigger, so I need to divide by numbers that are smaller than 6. So my only choice here would be 5.
You said smaller than 6, right?
Yes.
Okay.
If I want my answer to get larger, I need to divide by numbers that are smaller. Okay? So it's always opposite. So here, right now I'm dividing by 9. I want my answers to get smaller. So what choices can I use that will make my answers smaller?
10 and 12.
10 and 12. Because again, in order for it to get smaller, I need to guess bigger. Okay. 13. 3. Right now I'm dividing by 125. I want my answer to get smaller.
125.
125.01. It's still bigger than 125. Not by much, but it's still bigger. And 127 will work. Number 4. Right now I'm dividing by 0.35. I want my answer to get larger.
A, B, and D.
A, B, and D will all work for that one. So any of those guesses would help. And finally, number 5. Right now I'm dividing by 123.5. I want my answer to get larger.
B, and D.
B and D.
How would it be B?
Huh?
How would it be B? That's 122.
122.
And that's 123.
And that's 123.5.
Oh.
Okay. Questions? All right. So here's your next method. Jefferson has come along and said, you know what, Hamilton? Your method sucks. I like parts of it, but I don't like other parts. So still the same beginning steps. I need a standard divisor. So I still need to take my total pop, and I still need to divide by the number of seats. I still need to go through and get everybody's standard quotas. So I then need to take the state pops and divide by that standard divisor. Jefferson still liked that lower quota. So we're still, once we get that standard divisor, we're giving everybody a lower quota. What Jefferson didn't like is he said, it's not fair to go through and give everybody an extra seat, whoever has that largest decimal. That's not fair. That's not fair to other states. So what we're going to do is we're going to change this standard divisor as many times as we need to. So when we give everybody their lower quota, it finally comes to equal out that number of seats. Okay, it's a lot.
It is.
So this method will start with lower quotas and play the guessing game. Monday's method will start with upper quotas and play the guessing game. And the last method will do normal rounding and play the guessing game. So from here on out, it's guessing games. So this is how we do it. Here is your flow chart.
Okay, like where do I
As we do examples, it will make a little bit more sense. All right, so let's say my number of seats are 40. Let me actually raise this up a little bit more because I think the examples actually work a little bit better than the flow chart. Okay, let's say right now my standard divisor is 35. Okay, when I give everybody their lower quotas, we're only at 39. I need to hit 40. So I'm too low. I need it to get bigger. Well, in order for this to get bigger, this has to go smaller. When I go down to 33, I now become too big. Well, when I need this to come down, I need this to go up. It is nothing but a guessing game. Again, 70. I need to hit 150. So this needs to go bigger, so this goes smaller. I need this to go bigger still. This needs to go smaller still. I need this to go down, so this has to go up. Okay? So
Yeah, I get it.
I'm confused.
you're
I
fine.
get it.
I've got you. I have got you. It is going to be a pain. All right. So let's look at these three and then we're going to jump straight into Jefferson. Okay. All right. So if a divisor of 100 creates an over apportionment, okay, so that means I need my number to go down. If I am over, my number needs to go down, which means my standard divisor needs to go up. So which one of these would work?
Between 100 and 105.
Between 100 and 105. Okay, so a divisor of 64 brings me over, so I need to go down. 66.5 also takes me over, so I need to go down.
Smaller than 64.
I need to go smaller than 64. If a divisor of 135 is below, so this needs to go up, and then this also needs to go up. So if my answer needs to go up, I need to go down. So what do I need? Smaller. So this one was actually wrong. I needed to go down, so that means that needed to go up. So we should be bigger than 66.5. Sorry. So if my answer needs to go up, I need to guess a number that goes down. If my answer needs to go down, I need to guess a number that goes up. Okay. All right. So watch what happens here. All right. So we're just going to talk about this example before we do one. So there are 15 scholarships to be apportioned among 231 English majors, 502 history majors, and 355 psychology majors. So my states or my departments, who gets? My departments are getting scholarships based on the number of majors. So everybody's first step, no matter what method you're doing, this step never changes. Okay, your standard divisor will never, ever, ever change. So I get a grand total. We divide by the 15 scholarships. That gives me a standard divisor of 72.53. My standard quota step also will never change. So I then take each individual population and divide by that standard divisor. So we end up with lower quotas of 3, 6, and 4. So 13 is too small. So 13 needs to go up, which means when I guess a new number here, it needs to go down. So I need to guess a number that goes down. So that's what they did. They guessed 72. So they got new standard divisor. They divided everything by 72. Well, guess what? That really didn't change anything. So this number still needs to go up. So I needed to take this number and make it go down. So then they tried 70. They divided everything by 70. This time when they give the lower quotas, we get 3, 7, and 5. Now we're at 15. So now you can stop.
This is going to be like
Okay. But I'm going to show you the cheat way on the calculator so you don't have to sit there and divide and divide and divide. Your calculator will do it for you. Okay. So there are cheat ways. So this is going to be our first one. So what I want you to do, okay, what I want you to do is everybody grab their calculators. We might need to turn on a light so people can see their calculators. Okay. So everybody get their calculators. I'm going to show you the cheat. Sorry, people need to actually see their calculators. It's kind of dark in here because it's kind of crappy outside right now. Okay. So What I need you to do is first clear out your calculator. Everybody knows how to do that, right? Second plus 712. That clears it out every time. It'll say RAM cleared. Okay. So what I want you to do is I want you to go into y equals. Okay. For y1, I want you to put the population of math, so 245 divided by x. Okay. So each y is going to be a new population. So we've got math. In y2, I need you to put biology. So 481 divided by x. You have to put divided by x so your calculator will do it for you. Okay. Drop down one more. Political science was 654. Again, divided by x. Okay. First, we need to get a standard divisor. So my standard divisor is my total, so 1380 divided by what in this one? 40. We need to divide by 40. Did I lose anybody yet? We got this into y equals. We're finding a standard divisor right now. It tells you how many scholarships, that's how many seats you have.
Oh,
okay.
34.5.
34.5. So normally you would have to sit here and divide each one of those by that, right?
Yeah.
We don't have to do that anymore.
We don't? What?
Watch. So if you go back to your calculator, I want you to go to second window. This is where you tell your table to start. Instead of this reading 0, I want you to put in 34.5. Your standard divisor that you just got.
34.5.
Did you hit second window?
Window is up here at the top. It's right beside y equals. Yeah.
Did you get it? Okay, put in 34.5. Now I want you to hit second graph. Look what you get for Y1. 7.10. That's your standard quota.
Oh my. So what I hit after that?
When you go to Y2, 13.94 is your standard quota. If you need that last one, all you need to do is scroll to the right. There's your standard quota for the last one. Your calculator will do all the dividing for you.
What I'm saying.
Because I like to make it difficult.
No.
So we're at 7.10, 13.94, 18.96.
You just like that.
Wait, how did you what? She rounded.
I rounded it to 2 decimal places.
Do you have to?
If you're going to round, you need to round properly. Yes.
See, this is gonna trip me up later.
Well, then take it out to 3 decimal places. It's fine. Okay. So Jefferson's method says give out the lower quotas. 7, 13, 18. Well, when I add that up, I only get 38. So that means that this number needs to go up because it needs to be 40, which means I need to guess a number that is lower than 34.5. I really don't want to use these strategies because they suck. So we're not going to use them. So give me a number that's lower than 34.5. You said 32. All right. So 32. So at this point, you go back to your calculator and go back to your table start and make this 32, whatever you want to divide by now. And go back to your table. Okay, when I change your standard divisor to 32, we're now at 7, because remember, this is lower quotas, so just drop your decimal. So we're at 7, 15, and 20. We're at 42. Okay, so we did 34.5, and we ended up with 7, 13, and 18, which was 38. We said this needed to go up, so we made this go down. So now we guessed 32. This one now needs to go down, so this needs to go up. So I need to be somewhere that's lower than 34.5, but bigger than 32.
33.5.
You said 33.5? All right, so let's try 33.5. Again, go back to your table start. 33.5. Go back to your table. 33.5 takes me to 7, 14, and you said 19? Okay.
7 plus 4 plus 9.
Hold on. 7, 14, and that one's going to be 19.
Could it be more than just 1, 2? Could it be like 33?
No, it could just be a whole number. Okay. So 7, 14, and 19.
40.
We're at 40. You're done.
No, 34 gave you the same answer.
Okay. So Ashley just said she tried 34. And guess what? That gave you the exact same answer. 7, 14, and 19. That's the only thing that's nice about this method. Is Ivan's answer could be different than Cat Rice's answer, which could be different than Ashley's answer, and you're still correct. There is a range of numbers that you can use for a modified divisor and still end up with the same number.
Oh. I bet you were cheater for this. You can't even cheat.
Yeah, that's your
Okay. But again, this is what sucks about it, because if you're not good at guessing that standard divisor, you're screwed. Okay. So let's go to the next example. All right, here we go. We got to put all these into the calculator first. Okay, so we've got some gigantic numbers to put into the calculator. All right, so my suggestion to you is clear it out every time you start a new problem. Second plus 712. So 1,646,000. The biggest mistake I see is people forget to put divided by X. You have got to put that divided by X behind every one. That way, when you change your table start, it divides your numbers by X. If you don't, it doesn't do the division for you. So 6,936,000 divided by X. 154,000 divided by X. 2,091,000 divided by X. 685,000 divided by X. And my last one is 988,000 divided by X. Okay. I'll give everybody a minute to get that in. When you get that in, go ahead and give everybody their lower quotas and see what we need to do. So 32, 138, 3, 41, 13, and 19. So we're at 246. Everybody got these entered in? Okay, so we started off with 246 once we give everybody the lower quotas. So 246 needs to go up, which means my standard divisor of 50,000 needs to go down. What do we want to guess first? 45,000. All right, so go to your table start and put in 45,000.
Are they gonna be this big on?
They can be.
Oh man.
Okay, so we guessed 45,000. Somebody give me the lower quotas that go with 45,000.
36, 154,
36, 154,
3,
3,
46,
46,
15,
15,
and 21.
21. Okay, so 45,000 gives me 36, 154, 3, 46, 15, and 21. What?
It went too high.
Because you never because you skipped putting in this.
Oh, that's.
So make sure you have all of them in there. Hurry up. I want warm-up sun from now. Five. Uh-oh. Whoa. We were way off. We went way too far. So now this number needs to come down. So this number needs to go up. So I need something that's lower than 50,000, but higher than 45,000. You said 47. Okay, so we go back to that table start, 47,000. If you hit graph, it's going to take forever. You kind of have to shut it off or pull a battery out and put the battery back in. It takes forever sometimes. Yes. If you accidentally hit graph instead of second graph, it takes forever. So sometimes you just need to like pop the battery out and run with it. Okay, so now we're at 47,000. Somebody give me lower quotas because I didn't use that number.
35, 147, 3, 44.
35, 147, 3,
44.
44,
14.
14,
21.
21.
264.
264. Okay, 264. Again, we still need to come down, so I still need to go higher than 47,000. 49,000. All right. So again, you go back to your table start. 49,000. I have this one. 49,000. So that gives me 33, 141, 3, 42, 13, and 20.
It's 252.
252. We're still too big.
49,500.
I need to go lower than that, so I need to go higher than this. Well, don't forget, we can't go any higher than 50,000. We know 50,000 doesn't work. So you guys said 49,500. Why not go right smack in the middle? Guess what? That'll now give us 33, 140, 3, 42, 13, and 19. We're now at 250. You are finished. So that took us 4 guesses. So again, if you suck at the guessing game, this sucks. Okay.
For sure.
Okay. Do you see any violations that has happened in this method?
Oh, yes.
What has violated?
The lower quota. The algorithm.
It's none of your paradoxes. Your paradoxes are only part of Hamilton. So there's either an upper quota violation or a lower quota violation here.
Lower quota. Upper quota.
Upper quota violation. Who has an upper quota violation?
Oh, it's 140.
140. B. B's standard quota was 138.72, which means they should have never went lower than 138 or higher than 139. But they ended up with 140. So Jefferson's method causes upper quota violations. Okay.
So did state A.
State A did too?
No,
Yeah,
it's
it's
33.
No, it's 33. Their upper quota could have been 33. That's okay. All right. One more with me, and then I will just let you do example 5 on your own for homework. One problem.
Okay.
Okay. You like those odds?
Yeah.
Okay, so while Ivan's getting the rest of this down, go ahead and plug in your y equals 3.31, 2.67, 1.33, and 0.69. You good, Ivan? Okay. Second plus 712. Again, we go back to y equals, so 3.31 divided by x, 2.67 divided by x, 1.33 divided by x, and 0.69 divided by x. Okay, before we get started here, we need to get a standard divisor first. So 8 divided by what will give me my standard divisor? 160. 8 divided by 160 will tell me where I need to start. So 8 divided by 160 gives me 0.05. So in your table start to get your standard quotas, you would plug in 0.05. So you should be at 26.6 and 13.8. Okay, the decimals really aren't going to matter all that much in Jefferson, Adams, and Webster's method. So from here on out, we really don't need those decimals because we're not giving out seats according to the decimals. When I give lower quotas in, that gives me 66, 53, 26, and 13, which starts me off at 158. So this number needs to go up. So I need to guess a standard divisor that goes smaller. Okay. So we need to guess a number that needs to go smaller. So Ashley said, let's go ahead and start this off at 0.03. Okay. So in your table start, put 0.03. And I'm going to need somebody to holler off lower quotas because I do not have this. I did not guess this one.
110.
Woo! We went from 66 to 110. I'd stop right there. I wouldn't even continue on anymore. Okay? So we went way too low. So it needs to go up. I wouldn't even continue that one on. So give me something other than 0.03. We went way too far down.
0.05.
You said 0.045.
Yeah.
Okay? 0.045. Okay, let's try that one. Woo!
It's not that bad.
Yeah, that would have been like 300. and some freaking seats.
Oh, no, I was talking about 0.0.
Oh, no. So let's see how far off we are with 0.045. Where does that start me?
73, 59, 29,
73, 59,
15, 29, 15.
29, and 15.
Oh, 176.
You said 176. All right. Whew, that's at least a little bit better. Goodness gracious. All right.
0.049.
So this needs to come down. So this needs to go up farther. So I heard 0.049.
67, 54, 27, 14.
So that brought you down to 162. We're closer. Woo! So this still needs to go down. So this still needs to go up.
0.0492.
Okay, good. So be careful, because this is what kids struggle with. So let me talk about this for a minute. Because this is what kids struggle with, is the decimals and how to make this work. So we started with 0.05, and we said that needed to come down.
That's not going to work.
We're now at 0.049, and we said this needs to come up. Okay. In order to compare these, you can add zeros to the end. So technically, we needed to go lower than 0.050 and higher than 0.049. Well, the way we do that is we continue to extend to the right. So Louise said, let's tag on a 2. Okay? That's okay. We're still lower than this number, and we're higher than this number. Okay. So you said 0.042.
It's the same thing as before that.
Oh, well, that's not going to do any good. So I need to go higher than that, because you said this comes out to be exactly the same. So we didn't go high enough. Okay, so instead of 0.0492, what do you want to try? 0.0497. I didn't do that one either.
66, 53, 26.
66, 53,
13.
26, and 13. We're back to 158. So this needs to go up, so I need to go smaller.
0.0495.
0.0495.
5 not going to work.
Yeah, 5 isn't going to
You
work.
said 5 don't work?
No.
I got 66, 53, 26, and 13. We're still too small. 158.
2.6.
So this needs to go up. So this needs to go down. So you said let's try 0.049. Wait, this needs to go down. So 4, not 6. This will finally work. You finally get 67, 54, 26, and 13.
Wow.
Okay. That one took us 7 tries.
It took me 4. It's all working.
Yeah, it's going to be 3.
Oh, I had one.
Yeah,
You had one that worked?
Yeah.
While we were sitting there playing the guessing game, you had one that worked? Lat rice. Okay. So you have example 5 about Miss Gamble and her colored pencils. I want you to try Jefferson's method. When you get one that works, bring it to me and I will grade it. And then you will have no homework this evening or this weekend, free from math class. Yay!